electron configuration, because we were talking about the nucleus. And you know that the nucleus becomes very unstable when you have more neutrons than protons. In order for the nucleus to gain stability, that nucleus is gonna start emitting radiation until the number of protons and the number of neutrons are the same. Miramos, but besides the neutrons and the protons, we learn also that electrons, they are part of the structure of the atom. What's going to happen with the electron? What is the behavior of the electrons? That's what you're going to learn today. You were learning the other day how the different theories, they were evolving until they arrived to the modern atomic theory. The modern atomic theory, in which the scientists, they are explaining that the electrons, they are organized in different level of energy in the electron cloud. Copy this. Electrons are organized in the electron cloud following this rule. Following the rule. The rule is 2n to the second power, in which n is the level of energy. So let's say that I'm talking about the first level of energy, two multiplied by 1 to the second power, that's going to be equal to 2. So on the first level of energy, only 2 electrons can be organized. Questions? Second level of energy. On my second level of energy, I can organize until 8 electrons in there. You understand why, right? Because 2 to the second power is 4 multiplied by 2 is third level of energy. How many are going to be able to organize? How many electrons am I going to be able to accommodate in the third level of energy? They're not paying attention to me.
Is it 18?
18. And this is the most important lesson. Most important lesson. 1, 2, 3, that's the principal. Principal quantum number. Quantum number that at the same time is the level of energy. Questions about that? No? Okay. But Ramos, this is too easy. Oh, yes. First level of energy is divided in one sub-level or orbital. And that orbital is called orbital S and can only accommodate 2 electrons. So you have 1 orbital, 1 electron, 2 electrons. Second level of energy, 2 sub-levels or orbitals. S with the 2, P with 3 orbitals. 1, 2, 3, 4, 5, 6. So this 2 is able to accommodate 2. This one is able to accommodate 6 for a total of the 8 electrons that I can have in the second level. So the S orbital accommodate 2. By the p orbital is going to be able to accommodate 6 electrons. Okay, they're not paying attention to me, so I'm going to continue. Third level of energy. I have 3 sublevels or orbitals. S with my 2 electrons, P with my 6 electrons, D with 10 electrons. You remember that in the third level, you're able to accommodate until 18 electrons. So how many orbitals are you going to have in the D sublevel? 1, 2, 3, 1, 2, 3, 4, 5. And 2 electrons, they can be accommodated in each orbital. 4 level of energy. How many sublevels? How many sublevels? Orbitals. S, 1 orbital with 2 electrons. P, 3 orbital with 6 electrons. D, 5 orbital with 10 electrons. And F orbital, which is 7. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 7 orbital with 14 electrons. 14 electrons. And from the 4th level all the way down, you're going to have the same repeating orbital. S with 2 electrons, P with 6 electrons, D with 10 electrons, F with 14 electrons. Questions? No? Miss Ramos, how we're going to use all of this? What is today's objective? Any idea? You're not paying attention. Yeah, I'm not going to put an emphasis on you paying attention because I'm going to create a video. And if you have to watch this,
The goal today is to not piss you off.
Oh, mira, that's a good one. That's a good one. One of the objectives of today's class is that you are able to write the electron configuration of any element in the periodic table. When you are writing the electron configuration, you are organizing the electrons of that element in the different level and sublevel of energy, because when you are doing that, you can get information from there. I'm going to start with iron. And when you are writing the electron configuration, your first step is just to write the diagonal diagram. Let me put this over here. Ow. That name, remember that it was part of your vocabulary activity. I think that I have an F at the end too. Principle or law, I don't remember. According to that guy, remember, electrons, they're gonna occupy the level of energy or the orbital that has less amount of energy. S has less energy than P. S and P, they have less energy than D. S, P, and D, they have less energy than the F orbital. And that's why you have to create this diagram over here. The first line is representing the S orbital, second line P orbital, the third line is the D orbital, and the last one is the F orbital. How we're going to use the diagonal diagram to write electron configuration? Simple. Atomic number for iron, 26. How many protons?
26.
How many electrons?
26.
Why?
Because the amount of protons have to be equal to the amount of
Because
electrons.
the atoms, they are neutral. So I have to organize 26 electrons. Danielis!
Yes, Miss Ramos.
Am I sending text message? Okay, so but I'm gonna continue with this, Danielis. So I'm gonna start with my first level of energy, in which I have my s orbital with my 2 electrons. Remember that I have to organize 26. I'm gonna continue with my second level of energy, my s orbital with my 2 electrons, second level of energy. I have a p orbital also in my second level. Question for you, can I have a d orbital in level 2? Can I have a d orbital in level 2?
No.
What is the rule? N to the second power. Level 2 is 2 to the second power, which is 4 multiplied by 2 is 8. Can I have a d orbital in my level 2? Impossible, because I can accommodate up to 8 electrons on the second level. Okay, so I'm gonna continue. Okay, so my 1, my 2, 2p, 3s. 2, 3s, 3p. See que I'm following this line. 3p6, and now I'm gonna count because I have 10, 18, and instead of going to the 3D, see that I have to follow this. 4s2. Let me see, and after the 4, 3d10. I don't know how many I have. Let me count. 2, 4, 10, 12, 18, 18, 20, 30. But I don't need 30. So I don't need over here. Yes or no? Because I have to accommodate 26. So I have 2, 4, 10, 12, 18, 18, and 2, 20, plus 6, 26. Questions about that? Ms. Ramos, what is that? This is the electron configuration for iron. I do not have a periodic table in front of me, so I'm going to look at this ending. SD. Iron is located in group A, period 4. Look at the periodic table. And since the ending is a D, it's a transition metal. Right or wrong? They don't care. Okay, we're going to continue. Carbon, atomic number equal to 6, meaning that I'm going to wait for the result of the assignment in this part of the unit. Atomic number equal to 6, meaning that you have 6 electrons. Electron configuration, 1s2, 2s2, 2p2. 2p2. Why? Because I have 2 plus 2, 4 plus 2, they are 6. The number that you have in front, that's the quantum number, which is the level of energy number. S is representing the sublevel of the orbital, and that number over here is the amount of electrons that you have in that orbital. I don't have a periodic table in front of me, but I'm pretty sure that carbon is in group 14, period 2. How do you know that, Ms. Ramos? The 2 over here, the principal quantum number, is giving you the period number. The ending is SP, meaning that you're going to add this to number over here, 4, and then you're going to put 1 in front, 14. And it's a representative metal. In my days, we were not using 14. See, when you have this ending, this is group 4-8. And that's why when you look at some periodic table, instead of being carbon located on group 14, it's going to be located in group 4A because it's a representative element. Okay, they don't care about that. This is the electron configuration for carbon. But let's say that I want to draw the orbital diagram. Orbital. So for my first level, my 2 electrons, one up, one down. For my second level, S orbital, one up, one down. My p orbital has 3 orbitals, and I have to put 1 and 2 according to the Hunt rule on the Pauli exclusion principle. It has to be like that. If you do this, this is incorrect. Okay? So they have to occupy. The ones that are occupying the same energy level, okay, you have to organize first the ones that are spinning in the same direction before you are organizing the ones that are spinning in the opposite direction. Okay. And this over here is the orbital diagram for carbon. Orbital diagram for carbon. The last one that I'm going to say, I have 2 more. 11. 1s2, 2s2, 2p6, 3s1. Located in group 1, period 3, a representative metal. 1 and 2, 1 and 2, 1, 2, 3, 4, 5, 6, and I have over here my electron, que by the way, this is the valence electron, and the one that is going to be ready for bonding. Okay. Continue over here, 16. 1s2, 2p, no. 2s2, 2p6, 10. 3s2, 2, 2, 10, 12, 3p4. 2, 2, 4, 10, plus 6, 16. This is my electron configuration. 1 and 2, 1 and 2, my 3 orbital with my 6 electrons in here, my s orbital with my 2 electrons, and pay attention to this now. 4, 1, 2, 3, 4. I have to organize first the one that are spinning in the same direction to organize then the one that are spinning on the opposite direction. Okay, if you do this, let me see. If you organize those 4 electrons like this, that's wrong. Wrong. These 2 electrons that you have over here are the ones that are gonna be ready
Miss,
for bond.
Do you mind lowering your voice just a little bit? Because I can barely hear out of my left ear.
What happened?
Can you lower your voice just a little bit? Because I can't hear out of my left
I don't
ear.
know. I don't know what. I don't know. Maybe you have to lower your volume because I'm like a feet away from my computer. Like you shouldn't be having that amount of noise in there. orbital
Okay.
diagram over here. Lower the volume. This is the electron configuration. Questions? No questions.